Hello everyone, I am Shravani. I am pursuing MBA second sem in SVC College, Bangalore. Today I am going to explain about the data analysis and interpretation. It was an assignment given by Prasanna sir, subject related to RM and IPR. Data analysis definition. Cole defines data analysis as studying the organized material in order to discover inherent facts. The data are studied from as many angles as possible to explore the new facts. Purpose of data analysis. Data analysis serves several key purposes depending on the context in which it's applied. Generally, its primary goals include insight generation, transforming raw data into meaningful insights that can guide decision making. This might involve identifying trends, patterns, or correlations that were not immediately obvious. Second one is problem solving, analyzing data to identify the root cause of issues or inefficiencies and to find solutions. For example, business might use data analysis to understand customer churn and devise strategies to improve retention. Predictive analytics, using historical data to make forecast about future trends or behaviors. This could involve predicting sales, customer behavior, or market shifts. Performance measurement, assessing the effectiveness of strategies, process, or operations. For instance, companies might evaluate the performance of marketing campaigns or operational efficiency through data analysis. Informing decision making, providing a solid foundation or decisions based on empirical evidence rather than institution or guesswork. This helps reduce uncertainty and improve the accuracy of decisions. Methods used for data analysis in qualitative research. In qualitative research, data analysis methods are designed to interpret and make sense of non-numerical data such as text, audio, video, or images. These methods focus on understanding meanings, themes, and patterns within the data. Here are some common methods used for data analysis in qualitative research. Thematic analysis. Purpose: identify and analyze themes or patterns within qualitative data. Process: coding data into themes, reviewing and refining themes and interpreting the significance of these themes. Grounded theory. Purpose: develop theories grounded in the data itself rather than testing existing theories. Process: systematic data collection and coding to build theoretical framework, often involving constant comparison of data and theory. Constant analysis. Purpose: qualitative analyze the frequency and characteristics of specific words, phrases, or concepts within qualitative data. Process: coding text data and identifying patterns or trends in the frequency of certain elements. Narrative analysis. Purpose: examine and interpret the stories or narratives provided by participants to understand how they construct meaning. Process: analyzing the structure, content, or construct of narratives to uncover underlying themes or patterns. Discuss analysis. Purpose: analyze language's use and how it reflects and construction social realities, power dynamics. Process: examining language's communication patterns and the social context in which discourse occurs. Methods used for data analysis in quantitative research. In quantitative research, data analysis methods focuses on numerical data and statistical techniques to test hypotheses, identify patterns, and make predictions. Here are some common methods used for data analysis in quantitative research. Descriptive statistics. Purpose: summarize and describe the main features of a data set. Techniques: measures of central tendency, mean, median, mode, measures of dispersion, range, variance, standard deviation, and frequency distributions. Inferential statistics. Purpose: make inferences or predictions about a population based on sample data. Techniques: hypothesis testing, confidence intervals, and estimation. Common tests include t-test, chi-square test, and ANOVA. Regression analysis. Purpose: explore relationships between a dependent variable and one or more independent variables. Techniques: simple linear regression, multiple regression, logistic regression. Correlation analysis. Purpose: measure the strength and direction of the relationships between two variables. Techniques: Pearson correlation coefficient, Spearman's rank correlation and Kendall's tau analysis of variance ANOVA. Purpose: compare means across multiple groups to determine if there are statistically significant differences. Techniques: one-way ANOVA, two-way ANOVA, means across two factors and their interactions. Research objectives and questions. Alignment: ensure that the data analysis methods align with the research objectives and questions. The chosen method should help address the specific aims of the study. Considerations in research data analysis. When conducting research data analysis, several critical considerations helps ensure the validity, reliability and applicability of the results. Here are key considerations to keep in mind. Data quality and integrity. Accuracy: verify that the data is accurate, complete and free from errors. Consistency: check for consistency in data entry and measurement. Handling missing data: develop a strategy for dealing with missing data such as imputation methods or sensitivity analysis. Appropriate methods. Stability: select analysis methods that are appropriate for the type of data. Assumption: ensure that the statistical methods used to meet their understanding assumptions. Data cleaning and preparation. Pre-processing: clean and process data to remove outliers, correct errors and handle missing values. Transformation: apply necessary transformation to the data such as normalization or scaling if required by the analysis methods. Statistical significance and power. Significance testing: use appropriate statistical tests to determine if findings are statistically significant. Power analysis: conduct a power analysis to ensure that the sample size is adequate to direct meaningful effects or relationships. Data interpretation. Data interpretation is the process of making sense of data by analyzing its patterns, trends, and implications. It involves translating raw data into meaningful conclusions and insights that are address research questions or business objectives. Basic concept of data interpretation. The basic concept of data interpretation involves making sense of data by analyzing and understanding its meaning and implications. Here a straightforward overview. Understanding data. Data types. Recognizing whether the data is qualitative or quantitative. Data sources. Know where the data comes from and its context, including any potential bias or limitations. Identify patterns and trends. Trends: look for general directions or movements in the data over time or across different categories. Patterns: identify any regularities or recurring themes in the data. Analyze relationships. Correlation: assess whether and how strongly pairs of variables are related. Regression: examine how one or more independent variables influence a dependent variable. Interpret results. Finding: draw conclusions based on your analysis. What does the data tells you about the research questions or objectives? Significance: determine if the findings are statistically significant and if they have practical importance. Steps for interpreting the data. Interpreting data involves a systematic process to derive meaningful insights and conclusions from raw data. Here are the key steps to effective interpret data. Understanding the data context. Define objectives. Clarify the goals of the analysis. What questions you are trying to answer. Know your data. Understand the source of the data, how it was collected and its characteristics. Prepare the data. Clean the data. Address missing values, remove duplicates and correct errors. Transform the data. Convert data into a suitable format or scale if necessary. Descriptive analysis. Summarize data. Calculate basic statistics such as mean, median, mode, range, variance and standard deviation. Visualize data. Use charts, graphs and tables to represent data distributions, trends and relationships. Identify patterns and trends. Examine distributions. Look at how data is spread and identify any skewness or unusual patterns. Detect trends. Observe changes over time or across categories to identify constant patterns. Types of data interpretation. Data interpretation can be approached from various angles depending on the type of data, research questions and objectives. Here are some common types of data interpretation. Descriptive interpretation. Objectives: summarize and describe the basic features of the data. Methods: calculate measures of central tendency, measures of dispersion, and use visualization. Inferential interpretation. Objective: make generalizations or predictions about a population based on a sample. Methods: apply statistical test, t-test, chi-square test, ANOVA, and confidence intervals to infer properties of a larger population. Comparative interpretation. Objective: compare different data sets or groups to identify differences or similarities. Methods: use comparative statistics such as paired test, ANOVA, or non-parametric test and visualize comparisons with side-by-side charts or box plots. Relational interpretation. Objective: examine relationships or associations between variables. Methods: use correlation analysis to measure the strength and direction of relationships, and regression analysis to explore dependencies. Predictive interpretation. Objective: forecast future values or trends based on the historical data. Thank you so much for watching my YouTube video. If you like my video, do like, comment, share and subscribe.